Well, thank you, Jason. We do have a one question in the chat box, and I have one. Gene asks, how deep are you measuring soil carbon? Some data is showing accumulation at the surfaces, but still losing carbon at the deeper soil profiles.
Yeah, great question, Gene. Typically, the model, like some of the work that I showed on the LCA work in our context, is about 30 centimeters. Most of the larger work that we're working on now, we go down to a meter. And to your point, carbon can be it can move through those areas, right? And so it can change up and down the strata. There's areas like when we've done work out at Brown's Farm, for instance, where you might wish you could go 2 meters, because of the work that's down there. We do, though, still know that a majority of the carbon is going to be in that top 30 centimeters. And so for ease in a lot of what we do, that's where we stop. But if you talk about markets and other things, the new research, I didn't show you any of the research we've got from our McDonald's AMP projects, FFAR funded, but we went down a meter in all those projects. Future work, we're going down a meter as well.
Okay, the questions are starting to roll in now, Jason. At the ranch level, what should be measured right now so we can see change and capture the carbon credit in the future?
Yeah, so if we are going to say use this ranch hypothetically for actual carbon trading, it's going to take intensive monitoring. We're going to need to have long-term monitoring sites. We're going to need to understand the different textures of the soil to account for these differences. And we're going to need to go deep, and it's going to potentially require, interestingly enough, for instance, some of Paige's work in Berkeley, she was doing a power analysis to say, well, how many cores do I need in California to be able to detect, I forgot the number, at a P.05, but maybe plus or minus like 5 tons. And on one long-term transect, it was like 40 holes. Okay, it's crazy, right? The amount. And so it's going to take considerable intensive sampling. Hopefully, as the modeling becomes better, and that's really where we are right now, is we've got more simplified empirical modeling, like DNDC, which is a nitrogen turnover model that also looks at carbon. There's Comet that's out there that NORA uses that are much more simplified, that put in different types of moisture, grass growth, XYZ, other indicators, and spits out a predicted number for carbon. That's typically where we are right now. We also know that, and I think some of the modelers would say that those aren't necessarily the most accurate in the world. Perhaps over time they go from point A to point B, they can pick up differences, but it's going to take a lot of intensive monitoring, and then likewise there's going to be third-party verification in that. So I think things are going to have to continue to get better at that before we get super serious. But I think at minimum, understanding like the soil organic matter and understanding the fractionation is going to be really important.
Okay, Laura has a question. You mentioned there are a number of carbon markets trying to develop in the U.S., but there are largely variability in carbon sequestration. Are any of the calculators they're using to determine carbon sequestration volumes valid?
Well, I think I might have just answered that. I think that they can be valid. And again, often we're using modeling to do so. Typically, these models require a fair level of adjusting and management. I would say that probably in certain contexts, they're going to be more accurate, where you've got perhaps more homogeneous landscapes, concurrently landscapes that maybe don't see as much flux in carbon. So a Western landscape would see considerably less flux than what we might in a very temperate, non-arid environment like we do in Michigan, for instance, right? Or New Zealand, for that matter. So that's kind of, I think that probably covers it. If not, I can answer more.
Okay. Are there any studies looking at how different forage species affect cattle methane production?
Yeah, sure. And so, there are different forages that have certain phytochemicals that can work to offset or reduce methane. We know that the trefoils have those potential with certain amounts of tannins. many other types of forages that are out there. There are people that are looking at it. The reason I kind of, we always shoot for biodiversity in our mixtures. And in that, there are potentially some of those types of forages that might have, methane reducing capability. I tend to not really focus on it as much as trying to have that diversity. How impactful that is up for debate still. But there are definitely forages out there that do. In terms of feed additives, there are feed additives that we're doing quite a bit of work. You might see the work with different types of seaweeds. Algae is another. You can go back to ionophores like rumensin and monensin that are also concurrently reducing methane. And I think, very good technologies. Unfortunately, those are considered an antibiotic, which I don't agree with. But, I would love to still be in a natural grass-fed beef model and be able to use, be able to use an ionophore to, improve my gains a few tenths of a pound a day and also to lower the methane.
Okay, you want to just jump down to the next question, Jason?
Microbes. We're using Cornell tests. I also work in contexts where we're using Haney's work. So it's a function of not necessarily looking at total microbial. We can't get a total microbial biomass, but often we're looking at indicators. I've gotten to the point in my walk and journey, and a lot of this is I've tended to not as much focus on the microbes, but the outputs of the microbes. I think it's easier and it's cheaper, and it tells me what I need to know. So we've tended to focus more on water extractable organic carbon, water extractable organic nitrogen. We focus on active carbon if it's a Cornell test or their types of indicators. CO2 respiration is going to be another one. Those are typically the ones that we look at. I mean, we've spent a lot of money and a lot of time chasing the microbes. We need to do it. I just, when I get all these results, I have no idea what in the hell to say to a producer. Oh, well, you need to bump your ratio to this or that, or you need to do this and that. And I just don't know if it's the case, right? Like in our soils, I can get easily 100 stock days an acre on our ground, 3,000 pounds utilization. I have a fairly high bacterial ratio to fungi. I know that others I know, well, you got to get your fungi up. You got to get your fungi up. You got to get your fungi up. And I really haven't worried about it just because I'm productive. My grasses, I'm in a tame pasture environment. My grasses have adapted to high nitrogen. We know that bacteria tends to be in higher nitrogen environments. So I don't worry about it as much, but it doesn't mean that it's not important. Managed grazing compared to open land grazing out west. Yeah, I think there's a lot of differences there. It's a great question. And what I want to say is that, a lot of the data that I've seen out west tends to not see as pronounced differences as we do in more temperate areas, more non-arid areas. I also concurrently know ranchers that have applied managed grazing that have had considerable success, right? So it could be partly how we collect, how we do the science, those time and space variables. I tend to see, though, that even if we don't pick up huge differences, generally the papers I've read scientifically out west, Justin Derner, who's a colleague, does great work, still tend to pick up positive benefits from managed grazing in the Western U.S. Condensed tannins into alfalfa, that would be kind of rock star there, Gene. I like that idea a lot.